Welcome to your AI college. Today we will discuss about what is an AI agent. An AI agent is nothing but someone who can think, take action, and repeat all these actions until the task is done. Let's just understand this with a very simple example. Now let's meet this guy. He has a no brain to think and no hands to perform any action. He's just completely a blank person. On his own, he can't do anything. Now let's make him an AI agent. For making an AI agent, let's just give him an LLM. So LLM is just a brain to him, right? So with that he can think, right? But still he cannot perform any action because he has no hands or no tools, right? So let's just give him a tools also. Let's say we have given him a hammer. Now he has a LLM to think and he has a hammer to perform an action. Now at least this guy can perform an actions wherever hammer is required. And this is what the AI agent. An AI agent is someone who can think, take a action, and repeat these actions until the task is completed. Our AI agent is ready. Now let's give him a task. And the task is, hey buddy, here is a 5-inch long nail. Drive it into the wall, but leave exactly 1 inch outside so I can hang something on it. So the moment the LLM or the moment the agent got this task, it tried to think what all it need to perform this action. And then LLM or the agent understood that he has a tool, hammer tool, which he can use to drive the nail into the wall. Now this task or prompt goes to the LLM model. An LLM model thinks that it need to execute a hammer tool. And once the tool is executed, the tool response will goes to the LLM. And LLM think again that is the task is completed or not. If the task is completed, the response will return to the user. Now assume that this hammer tool push a nail 1 inch into the wall on a single run. But in our task, we have asked to keep 1 inch outside, meaning 4 inches has to be inside the wall. So when tool responded back to the LLM will think that this tool just pushed only 1 inch and has to execute the tool again. So this cycle will go on until only 1 inch left outside. Let's just build this agent. For this exercise, we're going to use LangChain framework and Ollama open models. First, we will create this agent using a create agent function in the LangChain. And then we'll create this agent manually without using this create agent function for better understanding. So let us start. And before we start, I hope you are aware of the Ollama, how we can pull the models, how we can run this model, right? And if you're not, I'll just give you the simple basic command for your understanding. So you can write like this Ollama list, right? You can install the Ollama and then can list. So whatever the available model that you have, it will show. So let's say I have just pulled this 4 models. So it's just showing all the 4 models. And if you do like this, okay, and if you want to pull another model, so you can do like Ollama pull model, and whatever the model name that you want to give, you can give here and it will let you pull this. And then if you want to remove any model, you can just do Ollama remove and the model name. Let us install the LangChain and LangChain underscore Ollama. So for that, we'll just do UV add LangChain. We'll also add UV add LangChain underscore Ollama. Okay, we have added both of them. Let's create an agent. So we'll write like create agent. Okay, and this is the function which is given by the LangChain only. Okay, and we'll just take this agent into the another variable. Okay, this is just a blank agent. Let's also define the LLM. So we'll say LLM equals to chat Ollama. We'll just give the model equals to Quen 2.5. We'll give some temperature equal to 0. Okay, we have the LLM. Now let's give this LLM to agent. So we'll say model equals to LLM. Now we also have to give the tools, right? So we'll just give the tools. So now let's just define the tool. Okay, for tool we'll write def, and as we are writing an agent, which put a nail into the wall. So we'll just give him a hammer, right? And hammer which will take and input something like the nail outside, the length of the nail which is currently outside. We'll just say int and it will return string. Okay, right now let's just give it pass. Okay, we'll give its definition little later. And we also have to decorate this function to convert into the tool which LangChain can use. So for that we have to use this tool annotation. Okay, we have the tool. Now let's just give this tool to this create agent function. Okay, hammer, and we have given this. Now our create agent, now our agent has the LLM and has the tool. Now this agent can accept any request or any task to perform, right? So we'll say agent. Okay, we'll say agent invoke. Okay, and invoke, and we'll say messages, and then we can just give him a messages. Okay, these messages we have to define. Okay, it was imported wrongly. Okay, now okay, these messages. So first let's define these messages. So we can say messages. Okay, messages, empty messages. Okay, and then we have to say messages dot append, and we have to give the human message. Okay, and human message content equals to task, the task that we wanted to give. And so let's also define the task equals to, so I have already written the task. Let me just copy paste it here. Let me copy paste this. So we here is the task. So we are giving a task to this agent that you are driving a nail into the wall. Initially 5 inches of the nail are outside, and your goal is to leave exactly 1 inch outside. Okay, so this is the task we are giving, and we have appended into the message, and then we are giving this message. Okay, we are giving this message to it, and then we are getting the response, right? We are just getting the response like this. And so let's just print this response. We'll say response messages, and we have to go to the last message and take its content. So we'll just print it right like this. Now this is the simplest we can do. Now let's just give the definition. Now let's just give the definition of this hammer function or hammer tool. And for that, first we'll give some kind of a comment which can help LLM to understand that when it need to execute this tool. So we'll say hammer the nail 1 inch deeper into the wall. Continue until only 1 inch remain outside. And then we also write if, or not if, we just write it returns the length of a nail which is outside after the tool execution. And then we will just write parameters. This we already have explained. I guess that would be enough. And then what we're gonna do, whatever the nail outside is there, we'll just subtract it by minus equals to -1, right? And then we'll just print something like uh, tool executed, so that we know that this tool is got executed. We'll just print it. So tool executed, and we'll just give the uh, okay, tool executed, and we'll give the nail outside. And then we'll just return, instead of this pass we'll just say return f, and we'll write like nail inch of the inch of the nail is outside. I mean, this is the remaining length of a nail which is still outside. So we'll give this definition like this. And now we have defined our model, we have our agent, we have defined the our human message, right? And we have added the human message also. And what we have also, what else we have to do? So I guess that's it pretty much. Let's just try to run it and see how it behaves. So yeah, let run this. Okay, so this LLM started and it called the tool. It executed first time. Then it think that my length is still 3. Then it hit it again, and then it understood. Okay, so now okay, great, it worked. So if you see clearly, on when we given him this task, it was a 5 length, right? 5 length of nail came here, okay, and then this reduced to the 4, and we printed this statement. So this size of the nail went to the 4. Now this 4 size, now this 4 size returned to the LLM. Now LLM thinking is again, right, and it's thinking that is the goal is achieved or not. But here is the length is 4, goal is not yet achieved. Then he execute the tool again. Okay, he'd execute the tool again, and now this time the length is just 3. Now again, when this tool return the 3, and LLM again is thinking that I just have to keep 1 inch outside, but I still have a 3. It means I have to again execute the tool. So it again executed the tool here. Okay, and again went for thinking, and again execute the tool, and again went for thinking. So it's like thinking, performing an action, observing the tool execution, and again performing an action until the desired outcome is reached or until the desired goal is reached. Now let's take another example. What we can do, instead of this 4 inches, we can write like 3 inches, right? And let me just execute this. So 2, okay, execute 2, 1. Great. Now we have successfully driven the nail so that only 1 inch remain outside, well, outside the wall, and we have achieved our goal. Now instead of this, what we can do? We can say I'll say 5 inch and just keep 2 inch outside, right? Let's just run this again. So it started with the 4. I mean, it given a 5, then it reduced to the 4, right? It given to the 4, it reduced to the 3, and given 3 reduced to the 2, and great. Now we are exactly the 2 inch of the nail outside, left outside of the wall. I hope by now you have understood this picture where we are giving a request to the model. Model is thinking and deciding whether it need to execute any tool or directly give the result. If it need to execute the tool, it is executing and observing its result. And on the observing the result, it can again decide whether it need to again execute the tool or just give the directly result. So that's what an agent. Now let's build this agent without using a create agent function of LangChain. Now we will going to build this agent manually, and we will be going to use concept like multi-turn conversation concept and available message type in LangChain, such as a AI message and tool message. If you are not familiar with these terms, I would highly recommend you to please give a pause, go and check out my another 2 videos, one on what is a multi-turn conversation concept and another available message type in LangChain, and then come back here and resume. Now let's remove this create agent function of LangChain and build this agent manually. So first we will just remove this. Now we have to bind this tool to the LLM directly. So we'll go to this chat Ollama and just say bind tools. And in the bind tools, we'll just give the available tool. So we have given the available tool. Okay, sorry, the name is hammer. Okay. And to resolve this compilation error, we just have to put this above the LLM. So we will put it here. Okay. Now this gone. Now this compilation error is gone, and we have our hammer tool. Okay, now we don't have to do this. Okay, let's remove this, just comment it out. We're going to use this line later. Now all we have to do is llm.invoke, and we have to give these messages. That's it. And we have to take into the response. Okay, now we'll just print the response. Okay, now let's just run and see what response we are getting from LLM. So what we are doing, we are simply creating one LLM, giving or binding the tools to it, and just giving this task. Okay, so now let execute this, and just I'll just put a breakpoint here. Okay, and let me put into the debugger. Okay, so we got the debugger point here. Let's just check what response the LLM responded with. So if you go in a response and check content is nothing, it's empty string. And if you go into the tools, you have one tool call. So this LLM is requesting one tool call execution, whereas giving the parameter, like what parameter it has to pass into the tool, and it also telling the which tool name it need to execute. Now let's write a code to execute this tool. Okay, and for that, let me just stop this, minimize it, and then we'll come here. We have the response, right? And we also have to do messages dot append, and we'll just give the AI message. Okay, AI message. AI message and content would be equals to response. But as the response itself is a type of AI message, so we don't have to wrap it again into the AI message. We'll just directly give this response. And again, if you're not familiar with this AI message and tool message, I would request and watch my another two videos on what is a multi-turn conversation and what is the available message type into the LangChain. Okay, now we have appended the message. We can start the while loop. We can say if my response is asking for any tool calls, right? Then I'll just start the loop, right? And I have to do this until all the tool execution is being done or not. Now we'll say that a response is containing a tool, means LLM is asking for execution of the tool. But if you paid the attention in the response, right, we have saw that LLM was giving a list of a tools, not just a single tool. It was giving a list of tool, and that list is just containing a one tool execution. It means we have to keep a loop here again. So we'll just say for we'll say tool call in tool calls. Okay, now we just need to get the name, right? So we'll just write tool name, tool underscore name equals to from tool name, from tool call we'll just get the its name. Okay, and then we'll also need to extract its argument. We'll say tool argument, right? We'll say tool call, and we'll say argument. Okay, so it will give the argument also. Now this tool call, we have the tool name and we have the tool argument. Now to invoke the tool, we would going to need the tool object, or maybe I would say the function object. But here we just have the name itself. We don't have anything with that. By the name we can get the tool object or tool function, right? So what we can do, we have to define a one dictionary here. So we can define a dictionary like we can say tool equals to, then we'll just say right hammer is the name, and have function object we can give like this, so hammer will give here. Okay, now we'll just use this tool here. So we'll just say tool equals to okay, maybe I'll just say is tools, right? Let's just call it tools, and we'll say tool equals to tools of whatever the name, the tool name that we have got from the LLM. We'll write this. Okay, now we'll just do tool dot execution, or maybe we'll just say tool dot invoke and pass the tool argument. Okay, we pass the tool argument. Now this will give the tool result. We'll keep into some variable tool result. Okay. Now we have this tool result. Now we have this tool result, and we have to pass this tool result to the we have to give this tool result to LLM again, and for that we're going to use a tool message. So we'll just say tool message. Okay, tool message content. We can say content is equals to your tool result, and we also have to give some ID to it. So which will give like this: tool underscore call underscore ID, and here it will have like tool call, and then we will have its ID. So I explained this in another video also, that LLM can request a multiple tool execution in single request only. And if it requests for multiple, and we also giving a multiple responses back to it, we have to attach that for which the tool execution request the response is. So for that we have to give the proper tool ID, tool call ID. So we are giving the same tool call ID. Okay, now we'll just keep into the tool message. I'll say tool message, or I'll say tool response. Okay, now let's just keep into tool response into the messages again. Messages dot append, I'll say tool response. Okay, so we have appended the messages. Now if there are if there are multiple calls, it will execute all of them and append all its result into the messages. Now once all the tool execution is done, now our messages have the tool execution result also. Now same we can send to the LLM again. So we'll say LLM dot invoke, and we'll give all the messages, and again we'll keep into the response. Now this loop will continue until the LLM is not giving any tool execution further. So it's keep on calling, it's keep on running into the loop until there is a no tool execution request is reached. Now, okay, so now what we have to do, we have to just append this also. Now I'll say messages dot append the response, and with this we can just directly print the response. Okay, and we'll write some couple of print statement for clear thinking. So let's say we write here is LLM is thinking. Let me write here. It's like first, because here we are giving first LLM invocation. So we'll just write print, and we'll say LLM is thinking. Okay, and then we'll say LLM is executing the tool, or maybe we'll say agent is executing the tool. Okay, and we'll also say print LLM requested the tool execution. So we'll write execution. So LLM requested for tool execution, agent is executing the tool, we got the tool response, and again we send to the back to the LLM. So again we'll write here print LLM is thinking. Okay, now let's just give a run to it. Okay, we got an error. Okay, we have to just do, instead of this comma, we have to use colon here. Okay, and we'll just check once again response. Okay, I guess we have to do this change also. Instead of response, you have to can just directly print the last message of this message a list. Okay, so we'll do like this. Now let me run again. Okay, LLM is thinking. We given the task, LLM is thinking. It requested for tool execution. Now our manual agent is executing the tool executed, and again this response went to the LLM. Now again LLM is thinking. Let's wait. Okay, LLM is thinking done. It executed the tool. Sorry, it requested the tool. It executed. Return the tool execution result back to the LLM, and LLM again is thinking. Now this loop, will go on until the desired output is come. Now this is the tool result. Return to the LLM. LLM is thinking again. Okay, perfect. Now there is exactly 1 inch of the nail left outside the wall. We have achieved our goal. Understood how the agent is actually calling the function, right? How the agent is getting the tool name, para argument name, right? All everything is getting in how it is calling. I hope by now you have understood what is an AI agent and how we can create this AI agent through manually and through the create agent function provided by the LangChain. If you really like our video, please hit a like and subscribe for more. Thank you for watching your AI College.